Our second lecture on electrochemistry, we'll start off by looking at a reduction potential chart. And this is a chart that you'll have if you need to use it on all of these cell potentials. Now the cell potentials are measured against hydrogen, and so the potential was against hydrogen. It was just assigned a voltage of 0 volts, and everything else is a comparison to our hydrogen cell. A galvanic or electrochemical cell are going to be spontaneous redox processes if we see that the cathode is electron poor, so reduction goes on there and it uses the electron, and the anode is electron rich, so oxidation will occur there. And so spontaneous electrochemical processes have the following characteristics. They have a positive cell potential, that's E superscript 0, and that's at a standard condition, and also they have a negative delta G value. A copper zinc cell, which is shown here. We have copper over at the anode, or excuse me, zinc is at the anode and copper is at the cathode. So our copper is going to gain electrons and our zinc will be losing electrons. And if we want to look at this cell, we would look at the standard table, and you notice that the electrons for zinc are on the reactant side and they need to be on the product side. So we'll have to flip that reaction, remember Hess's law, and we have assigned our copper to be there at the cathode, so it has a positive voltage. And then when we flip the zinc over, you see that the cell potential changes. You just add those up and it will be a positive 1.10 electron volts. These are not molar amounts, so we don't worry about that there's 2 electrons in there. We just do the calculation straight.